All right, on number one, we are just determining how many solutions we have to each of these equations. So if I look at my graph, I'm looking to see, well, how many times does this parabola have a y value of 0? So one way that we can go about this is just drawing a horizontal line through at 0 and seeing how many times our graph hits that line. So in this case, I see that it hits 2 places, so that means there are 2 real solutions, 2 solutions that I can see on my graph. If I do the same thing for a y value of 3, again, just kind of drawing a horizontal line here at 3, I see that I just hit 1 time right here. All right, so that means that this equation has 1 real solution. The last one, if I again do the same thing and draw a horizontal line up here at y equals 5, I see that my graph does not hit that line at all. So before, we would say that this meant our graph had no real solutions. But now that we know about imaginary solutions, I can say that this means if there are 0 real solutions, my graph has to have 2, or my equation, I should say, has to have 2 imaginary solutions. These are the only 3 possibilities, right? Either we have 2 real solutions, 1 real solution, or 2 imaginary solutions. We will never just have 1 imaginary solution. On number 2, we are solving this quadratic equation 2 different ways. 1, using the quadratic formula, and 2, by completing the square. So, first, if we look at Tyler's method using the quadratic formula, he made a mistake somewhere. It actually ends up being right here. In the quadratic formula, when we square b, we need to make sure that we are putting that in parentheses. So if I take -10 and square it, I should get positive 100. That's his mistake, okay? This should be positive 100. So it says also provide the correct answers. So let's finish out the problem and fix it. So that means if I do positive 100 minus 116, this should be just -16 inside of my square root. And then to simplify the square root of -16, we can split that up into the square root of 16 times the square root of -1, which would just be 4i. The square root of 16 is 4, and the square root of -1 is I. So that means this part here should be 4i. So I should have 10 over 2 plus or minus 4i over 2. And then we can reduce each of those fractions. So the 10 over 2 reduces to 5, and then 4i divided by 2 just reduces to 2i. So I should get 5 plus or minus 2i. So let's do the same problem then by completing the square. So John solved by completing the square. So on his first step, he subtracted the 29 over, and then he said, okay, well, I need to add the same thing to both sides. So remember, when we are completing the square, that value that we are adding to both sides should be whatever my b value was. In this case, that's -10 divided by 2 squared. So -10 divided by 2 is -5. -5 squared is positive 25. So it looks like he did that part correctly as well. So then we can simplify. On the right side, -29 plus 25 does in fact get us -4, so that looks good. On the left side, we can factor this. Now remember, we can go the long way and x factor it, right? But the shortcut is that since we created a perfect square trinomial over here, this will always factor into x, and then this value here will always be b divided by 2 squared. Now the whole point in doing that is now I can take the square root of both sides. right? So if I take the square root on the left side here, the square and the square root cancel out, and I just get x minus 5. On the right side, though, the square root of negative 4 is not negative 2. This was his mistake. If we simplify the square root of negative 4, kind of like we did over here, I can split that up into the square root of 4 times the square root of negative 1, which would be 2i. Now, we also can't forget that when we take a square root as part of our solving process, we will get a plus or minus. So he actually kind of made two mistakes here. He didn't have his plus or minus, and he didn't include his I. So right here, we should have x minus 5 equals plus or minus 2i. The last step to solving then would be to add the 5 over to the other side. And now I've got 5 plus or minus 2i on the right side. Those are not like terms. I can't combine them. So that's how I would express my final answer. And that's the exact same thing we got over here using the quadratic formula, right? So either way, using quadratic formula or completing the square, we should get the same answer. The rest of the problems we are just solving using the method of our choice, either quadratic formula or completing the square. I'll kind of walk through which method I would choose, which one I think would be easier. So on 3 here, if my only choices are quadratic formula or completing the square, on this one, since my b value is odd, completing the square will be challenging. So I'm going to set this one up by quadratic formula. I already have everything on one side equal to 0. So right off the bat, I can identify my a, my b, and my c. So my a value, the coefficient on x squared, is 1. My b value, the coefficient on x, is negative 9. And then my c value, the constant, is 14. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Just plug all these values in. So the opposite of b, so the opposite of negative 9 would be positive 9 plus or minus the square root of b squared, so negative 9 squared minus 4 times a times c, all of that over 2 times a, which in this case a is 1. And then I just simplify from here. So underneath of my square root, negative 9 squared would be positive 81, and then negative 4 times 1 times 14 would be minus 56 all over 2. Inside my square root then, 81 minus 56 is 25. And now, in this case, since 25 is a perfect square, I can simplify this to just 9 plus or minus 5 over 2. So from here, since this will work out to nice values, I want to split this up and write this as 9 plus 5 divided by 2, and then separately 9 minus 5 divided by 2, and simplify as far as I can. So for this first answer, 9 plus 5 is 14, and 14 divided by 2 is 7. For my second answer, 9 minus 5 is 4, and 4 divided by 2 is 2. So I get two nice answers here, 7 and 2. So at this step, if this is a perfect square, we want to keep going and simplify until we get to here. On number 4, this one, I would probably complete the square. Since my leading coefficient is 1 and my b value is even, this is set up nicely to complete the square. So the first thing I will do is subtract my constant over to the other side. So I'll have x squared minus 2x, and then I'll leave my plus blank here on both sides. So now that blank, Remember, that blank is going to be whatever my b value is divided by 2 squared. So in this case, my b value is -2. -2 divided by 2 is -1, and -1 squared is +1. So I'm just going to be adding 1 to both sides of this equation. On the right side, -5 plus 1 is just -4. On the right side, we have created a perfect square trinomial, so this will factor into a binomial squared. The shortcut is this will always be b divided by 2. So my b value was -2. -2 divided by 2 is -1. I'll put a little reminder there. That's always b divided by 2. Now, remember, if we don't remember that shortcut, we could go the long way and x factor this, right? I could set up my x factor and look for two numbers that multiply to 1 and add to -2. From here, then, I can now just take the square root of both sides. So, on the left, square and square root cancel out. I just get x minus 1. On the right side, the square root of -4, well, I can simplify that into the square root of 4 times the square root of -1. So the square root of 4 is 2. The square root of -1 is I. And don't forget your plus or minus whenever we take a square root. So the square root of -4 plus or minus 2i. My final step to get x by itself would be to add the 1 over to the other side. So I get x by itself. And now over here, the 1 and the 2i are not like terms. I cannot combine them. So my final answer will just be 1 plus or minus 2i. Don't forget that plus or minus has to stay with this value. So I can just write my final answer like this. On number 5, since my a value is not 1, I'm probably going to set this up using the quadratic formula. So off the bat, I can identify my a as 3, my b as 4, and my c as 6. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And just plug in our values. So the opposite of 4 plus or minus the square root of 4 squared minus 4 times a times c all over 2 times a. And then we just simplify from here. So inside of my square root, 4 squared is 16. And then -4 times 3 times 6 would be minus 72 all over 6. 16 minus 72 would be -56. Now from here, I'll come up here to finish this off. I want to split this up into two different fractions. So I can write this as -4 over 6 plus or minus the square root of -56 over 6. Now, the reason that I want to do this is I want to see if I can reduce this fraction. -4 over 6 does reduce to -2/3. Now, over here, I cannot reduce this fraction because the 56 is inside of the square root and the 6 is outside. But what I can do is, since I have a negative inside of the square root, I need to pull that out as an I. So the square root of -56 I can write as I times the square root of 56. Remember, the logic behind that is I could split this up into the square root of -1 times the square root of 56, and then we know that the square root of -1 is just I. So this should be my final answer. negative 2/3 plus or minus I times the square root of 56. Now, just one little side note. Remember, if I wanted to write this as two separate answers, this means one of my answers would be negative 2/3 plus I times the square root of 56 over 6, and then my other answer would be negative 2/3 minus I times the square root of 56 over 6. All right, so this would be one answer, and then this would be my second answer. On number 6, this one I think is set up nicely for completing the square because my a value is 1 and my b value is even. So I will start by moving my constant over to the right side. I'll add the 22 over. So x squared plus 6x, and then I'll put my plus blank on each side equals 22 plus blank. So now I need to figure out what value to add to both sides to complete the square. The value that I'm adding to both sides should be b divided by 2 squared. My b value is 6. 6 divided by 2 is 3, and 3 squared is 9. So I should be adding 9 to both sides. So on the right side, 22 plus 9 is 31. On the left side, we have created a perfect square trinomial. So this will factor into x, and then this value here will always just be whatever my b value was divided by 2. In this case, my b is 6. 6 divided by 2 is a positive 3. From here, I just need to take the square root of both sides. So on the left side, square and square root cancel out, and we just get x plus 3. On the right side, whenever we take a square root, plus or minus, and 31 is not a perfect square, so I'm just going to leave that as the square root of 31. The last thing, to get x by itself, subtract the 3 over. So I'll get x equals negative 3 plus or minus the square root of 31. On number 7, I need to start by getting everything on one side equal to 0, right? So I need to get my constant values together first. So I will add the 3 over and get 2x squared minus 8x minus 6 equals 0. Now, I notice that everything on the left side is divisible by 2. So to make this problem easier, I'm going to go ahead and divide both sides of my equation by 2. Okay? Whenever we recognize that, that's going to make the problem a lot easier. So 2x squared divided by 2 would just be 1x squared. Then negative 8x divided by 2 would be minus 4x. And negative 6 divided by 2 is minus 3. So, I mean, since we already have everything on one side equal to 0, we could use quadratic formula. But it might be a little bit less work from here if we complete the square, because my a value is 1 and my b value is even. So I'm actually going to move this 3 back over to the other side. So x squared minus 4x plus my blank equals 3 plus blank. So the value that goes in my blank will be b divided by 2 squared. My b value is negative 4. Negative 4 divided by 2 is negative 2, and negative 2 squared is 4. So I need to add 4 to both sides. So on the right side, 3 plus 4 is 7. On the left side, we've created a perfect square trinomial. So this will factor into x, and then this value here is always just b divided by 2. So negative 4 divided by 2 is negative 2. From here, I can take the square root of both sides. So we get x minus 2 equals, remember, whenever we take the square root, plus or minus, and 7 is not a perfect square, so I will just leave that as plus or minus square root of 7. And the last thing I need to do to get x by itself is add the 2 over to the other side. So I'm out of room, so I will come up here to write my final answer. 2 plus or minus the square root of 7. On number 8, again, I need to start by getting everything on one side, so I'll subtract my 1 over. I'll get 2x squared plus 3x plus 6 equals 0. Now on this one, my leading coefficient is not 1, but I still can't divide it out. Like on the last one, everything was divisible by 2. That's not the case here. 3 is not divisible by 2. So this one is probably set up to best use the quadratic formula. So I see that my a value would be 2, my b value would be 3, and my c value would be 6. So if I plug those into the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the opposite of 3, negative 3, plus or minus the square root of 3 squared minus 4 times a times c all over 2 times a, and then we just simplify from here. So negative 3 plus or minus the square root of 3 squared is 9, then negative 4 times 2 times 6 would be minus 48, all over 2 times 2 is 4. So inside of my square root, 9 minus 48 is negative 39. So now from here, I want to split this up into two fractions. So negative 3 over 4, plus or minus. And now here, I'll go ahead and simplify this. In my second fraction, I've got a square root of negative 39. Remember, that negative inside of the square root can get pulled out as an I. So I could write this fraction as I times the square root of 39 over 4. Then we still need to check to make sure that, or see if we can reduce this fraction. Negative 3 over 4 does not reduce. So I'm done. This would be my final answer.